Listen closely. What you are about to see today is not a movie. It is not science fiction. It's not the fever dream of a mad engineer. What you are going to witness is the construction of the most expensive weapon humanity has ever forged. An aircraft that costs more than its own weight in solid gold. That isn't poetry, it's pure mathematics. And in a moment, I'm going to prove it to you. It's called the B-2 Spirit. And if you've never seen it in person, your brain will struggle to believe what your eyes are recording. It has no tail, it has no fuselage. From certain angles, it is quite literally a black line floating in the void. But its shape isn't the most disturbing part. The most disturbing part is how it's made. Because manufacturing a B-2 isn't just engineering. It's something hovering on the frontier between science and what used to exist only in the imagination. Today, you are stepping, for the first time, into that process. Step by step, from the first sketch to the first flight. Stay, because this is only the beginning. To understand how the B-2 is built, you first have to understand that this plane was born from a destroyed obsession. In the mid-20th century, there was an engineer named Jack Northrop. Northrop was the kind of man who saw the world through a different lens. While everyone else was designing planes with long fuselages, high tails, and vertical stabilizers, he looked at all that and asked, "What for?" To him, all of that was dead weight. It was air resistance. It was inefficiency. His vision was radical. A plane that was only a wing. Nothing else. Pure lift. Pure aerodynamics. In the 1940s, he built his prototypes, the YB-35, the YB-49. He flew them, he tested them, and they worked. But they were uncontrollable. Without a tail, without stabilizers, flying that plane was like trying to balance a needle on the tip of your finger. Any gust of wind, any slight variation, and the machine would plummet. Several crashed, several pilots died, and finally the Air Force made a cold, final decision. They ordered the total destruction of every single airframe. History says Jack Northrop was there. He watched with his own eyes as his creations were sliced into pieces by industrial saws. His dreams turned into scrap metal. But this is where the story becomes absolutely haunting. Decades later, old and confined to a wheelchair, Northrop received a call. They took him to a hangar. A secret hangar. They placed a box in his hands. Inside was a scale model. It was the B-2 Spirit. The flying wing he had imagined, realized. Finished, invincible. Northrop opened that box, looked at the model, and wept. Now I know why God kept me alive for so long. That is the DNA of this aircraft. A dream that took half a century for humanity to invent the tools necessary to make it real. In the late 1970s, the United States had a problem. The Soviet Union had built the densest air defense network in history. Chained radars, thousands of surface-to-air missiles, hypersonic interceptors. Any conventional aircraft attempting to penetrate that shield would be turned into a fireball before even seeing the target. The Pentagon asked a question that would change the course of history. Is it possible to build a plane that is invisible to radar? Not hard to detect. Not low signature. Invisible. To answer that, they did something never before seen in aviation. They handed the problem to a supercomputer. Because the B-2 cannot be designed on paper. There is no human engineer capable of calculating in their head how every millimeter of that surface must curve so that radar waves slide off without reflecting back. We are talking about trillions of variables, millions of angles, electromagnetic interactions that shift based on frequency, temperature, and altitude. The computers of the 80s, the most powerful machines on Earth, labored for years modeling the perfect shape. What they produced was something no human would have dared to imagine. A giant boomerang. No sharp edges, no flat surfaces. Continuous curves at every single point. Why curves instead of facets, like the F-117 Nighthawk? Because facets, the flat triangles, work, but they are primitive. They scatter radar. The B-2 needed more. Continuous curves don't just scatter the signal. They make it slide, like trying to grab mercury with your bare hands. But the design had a brutal flaw. A flying wing is aerodynamically unstable by nature. Without a tail, the plane wants to tumble in every direction. It's like designing a race car without a steering wheel and expecting someone to drive it at 200 miles per hour. The solution came from something Northrop didn't have. Fly-by-wire. a system of flight computers that monitors the aircraft and moves the control surfaces thousands of times per second. The pilot doesn't fly the B-2 directly. The pilot suggests to the computer where to go. The computer does the math. Without that digital brain, the B-2 would be ripped apart by its own physical laws in a matter of seconds. This is where the numbers become absurd. The B-2 Spirit has an official cost of $2.1 billion per unit. $2.1 billion for one single plane. To put that into perspective, if you took that money and bought pure gold, the most precious metal on the market, and you built a solid gold B-2 of the exact same size and weight, the gold plane would be cheaper than the real one. I'm not being hyperbolic, that is literal mathematics. Why does it cost so much? The answer lies in what is inside, and more importantly, what is on the outside. The B-2 isn't made of aluminum like a normal plane. It is built from advanced composite materials, carbon fiber, high-performance polymers, structures that didn't even exist in civilian industry until this military program invented them. But the most expensive, most secret, and most critical component of the entire manufacturing process is something you can't even see with the naked eye: the stealth coating. The skin of the B-2 is covered in layers of radar-absorbent material, RAM. Special paints, composite tapes, microscopic structures. How do they work? When a radar wave hits a normal plane, it bounces back to the receiver. The radar says, there is something there. When it hits the skin of the B-2, it vanishes. The materials convert electromagnetic energy into heat. Instead of reflecting, they absorb. It's as if the plane breathes in the radar and exhales nothingness. The exact composition of those materials is a state secret to this day. 30 years later, classified, no public access. But we do know that applying that coating is one of the most delicate industrial operations in existence. Every layer is applied with micrometric precision. Because if there is one bubble, one imperfection, one layer too thick or too thin, the radar signature changes. And the ghost is no longer a ghost. The B-2 is assembled at Northrop Grumman's facilities in Palmdale, California. But calling it a factory is an understatement. It is a cathedral of high technology. The process begins with the structure. Wing sections are manufactured separately using laminated composites. Each piece is cured in giant autoclaves, pressure ovens that cost millions of dollars, where heat and pressure mold the materials into their final rigid form. The tolerances are extreme. We are talking about tenths of a millimeter. Why so precise? Because any irregularity on the surface, any step, any gap, any deformation, creates electromagnetic turbulence. And that turbulence is detectable. An imperfection the size of a coin can make the B-2 scream on an enemy radar. Then come the leading edges. These edges are one of the best-kept secrets of the program. Inside, they have a sawtooth structure, an internal architecture that literally traps the electromagnetic energy coming from the front. If the radar hits there, it enters a trap. It bounces inside, it degrades, it dies in there. Next, the engines. The B-2 has 4 General Electric F118-G E-100 turbofans, but unlike any other plane, you can't see them from the outside. They are buried deep within the wing. Why? Because an engine creates 2 detection problems. First, the infrared signature. The heat it emits can be tracked by heat-seeking sensors. Second, the radar signature. An air intake is a hollow metal cavity. Without protection, it acts like a perfectly oriented radar reflector. Engineers solved both with brilliance. For the heat, they designed an exhaust system that mixes super-hot turbine air with cold ambient air before venting it over the rear wing surface. The rear wing is covered in ultra-resistant ceramic tiles to withstand that temperature. The result, the B-2's thermal plume is practically invisible at a distance. For the radar, the intakes have grills and S-ducts calculated so that no radar wave can reach the metallic blades of the engine and bounce back. And here is one of the most incredible details of the entire build. The B-2 leaves no contrail. That white trail planes draw in the sky, the line that tells everyone exactly where you are. The B-2 suppresses it. How? By injecting chemical compounds into the exhaust that prevent the formation of ice crystals. No trail, no visual footprint, no white line in the sky. The plane passes over your head and the sky remains exactly as it was before. When all sections are ready, final assembly begins. This is not like building a car. There is no fast-moving assembly line. B-2 assembly happens in completely controlled environments, controlled temperature, controlled humidity. Even the dust particles in the air are monitored. Why? Because the stealth coating is hypersensitive. A single dust particle trapped under a layer of RAM can create a microbubble. At 40,000 feet in -50-degree temperatures, that bubble becomes a crack. And that crack becomes a beacon for enemy missiles. Technicians work with laser precision tools. Every joint, every panel, every edge is verified with electromagnetic scanners. When assembly ends, the plane moves to the final coating application. This is the most delicate moment. Specialized teams apply layers of absorbent material following classified protocols. Each zone of the plane has its own process, its own material, its own layer count. Once applied, the coating cannot be easily touched up. If something fails, entire sections must be sanded down, cleaned, and reapplied from scratch. The cost of that coating alone, the material, the specialized labor, the time, is a massive fraction of that $2 billion price tag. Before a B-2 flies a real mission, it undergoes months of testing. Flight tests. Test pilots push the plane to its limits of speed and maneuverability. They verify the fly-by-wire system reacts correctly in all conditions. Radar signature tests. This is the holy grail of secrets. There are specialized facilities, radar cross-section ranges, where the plane is illuminated with signals from every frequency. The results measure the B-2's radar cross-section, RCS. While classified, technical estimates suggest it is comparable to a large bird. A plane with a 170-foot wingspan that appears on radar as a sparrow. Endurance tests. The plane is designed for missions lasting over 40 continuous hours. 2 pilots, locked in that cockpit, from Missouri to the other side of the planet and back. No stops, no landing, just mid-air refueling over the dark ocean. They have a chemical toilet, a small microwave, and a sleeping mat to take turns, and potentially enough nuclear firepower in the bays below to end a civilization. Here is what few people realize. The manufacturing of the B-2 doesn't end when it leaves the factory. Maintaining a B-2 is an industrial operation in itself. For every hour it flies, the plane requires nearly 60 hours of maintenance, 59 hours of labor for 1 hour of flight. Why? Flight vibrations create microcracks in the stealth skin. Temperature changes between the stratosphere and the runway stress the materials. Humidity, heat, pressure, everything attacks the ghost's skin. When the B-2 lands, a team of specialized technicians swarms the aircraft. Laser scanners, high-resolution cameras, every inch of the coating is inspected, every crack is cataloged and repaired. And these repairs can't be done by just anyone. These are technicians with years of training in materials that don't exist in any other industry on Earth. Furthermore, the B-2 cannot sleep just anywhere. It needs climate-controlled hangars. If you expose it to intense rain or extreme humidity without protection, the coating degrades. In fact, the only B-2 crash in history, the Spirit of Kansas in 2008, was caused by humidity. A little bit of condensed water in 3 pressure sensors. The sensors sent the wrong data. The computer thought the plane was diving. It ordered the nose up during takeoff. The plane stalled and fell. $2 billion turned into ash on the runway because of a few drops of water. The pilots ejected. The plane did not. And when the Spirit of Kansas was lost, it wasn't replaced, because the production line was already closed. Today, only 20 operational units remain. 20 planes in the entire world. There are no easy spare parts, no inventory to pull from. Every damaged component of a B-2 requires specialized manufacturing processes that take months. The successor to the B-2 already exists, the B-21 Raider. Smaller, more efficient, cheaper to maintain. The Air Force plans to buy more than 100, but the B-21 cannot replicate one thing: 30 years of proven combat history. The B-2 flew in Kosovo, Afghanistan, Iraq, Libya. Every mission generated data, lessons, and improved protocols. The B-21 starts from zero. In strategic aviation, accumulated experience is worth as much as the technology itself. The B-2 will keep flying well into the 2030s. When the last B-2 lands for the final time, something unique will be lost. Not just a plane, not just a military platform, a level of industrial ambition the world may never see again. Because when the B-2 was built, the United States made a radical choice. To manufacture something so complex, so expensive, and so difficult to maintain that virtually no other nation on the planet could ever hope to replicate it. And it worked. For 30 years, no adversary has been able to challenge the B-2's ability to reach any point on Earth undetected. That is power. And that power was born in a factory. Piece by piece, layer by layer, millimeter by millimeter. The next time you look at the night sky and see it clear, absolutely empty. No planes, no lights, no sound. Think about this. The B-2 Spirit could be exactly above your head right now. And you would never know. That is what costs $2.1 billion. That is what takes years to build. That is what thousands of engineers and scientists dedicated their lives to creating, the power to be anywhere without anyone knowing you are there. If this analysis blew your mind, let me know in the comments. Do you think it's worth the cost? Or is it a dinosaur that has no place in the era of drones and hypersonic missiles? Like, subscribe, hit the bell, because this is only the beginning.